The calendar is updated online. So remember 6.1, I was trying to go up and I went down. 6.1 due today. We're going to go over question 6.2. We're going to be starting today, but there's only one homework on 6.2, one big homework. But what do you see back on the board as far as notes? What are we covering today? Section 6.2A. And then we're going to be covering section 6.2B, and then put those two together. I want them separate in your notes because they, even though they're both volumes, one is a particular type of volume, and the other one, like the one is very general. The one we're going to talk about today is the general idea of volumes and how we can get volumes with integration. Because remember, chapter 6, integration, applied areas, and volumes. So today, section 6.2A, today and probably Monday, is the general idea. Think MVT, the general all-encompassing idea. And then 6.2b says, no, let's zero in, let's get focused. You can even think with differential equations, general differential equations, and then specific exponential growth and decay. Except this one, both of them, 6.2a and 6.2b, are going to be on the AP. I can guarantee it. Maybe on FRQs, maybe on multiple choice, maybe on both. But we have to know how to do both the general idea and the very specific idea. And 6.2 is due next Friday. So what's going to be really easy to do? Procrastinate. This weekend, I don't think you'll be able to do much homework. So what's my advice? Check out a CalcAB video or two. Check out a Patrick JMT video or two. And it can be on areas, but I would say probably volumes. And when we get into notes today, when it's volumes by cross-sections, be looking at cross-sections, maybe be looking ahead. But instead of doing book work this weekend for calculus, because our corrections are supposed to be in for chapter 4B, you're waiting on your chapter 5 test because I have kids like Nick and Thomas who haven't taken it yet. Sorry, you guys aren't doing well. Hang in there. But coming back, if you're not able to go ahead and homework, I would say check out some videos this weekend. Sound good? Okay, cool. It'll be beneficial, and whatever you find, and if you're trying a few different ones, whatever you find, if you're like, I like how that guy explains, then next week you can keep watching those videos from that guy. Does that make sense? Or that girl. Sorry, there's that calculus girl too. I think to that end, logistically, that's about it that we need to talk about, except I forgot until, I don't know, yesterday or the day before, that I never actually gave you guys an update as far as our mock AP, and I apologize for that. Like, I made the decision and I never actually mentioned it. So sadly, it used to be my board kind of cut off and I could put things at the bottom, but now I can't. Okay, I'm going to write it over here. We did all the voting. I did all the comparing. I did what I thought was best and wisest in keeping with my ultimate goal of having the most people take it on the actual, but also in keeping with my goal of wanting you to do well on it. Putting the two together, I have decided, and I will not change my mind, that our mock AP, my French people, I know it doesn't even affect you because you have to make it up anyway, but our mock AP is going to be Saturday morning, Saturday a.m., from 8 to noon. I'll just put Saturday morning. Parents, etc., if you need to put a reminder, from 8 to noon in the library, and that is April 13th. It turned out at the end of the day, there were only 2 people that couldn't do it in the morning, or I should say the count of who could. Some people couldn't do it Friday night either. So we had some people that couldn't do it Friday, could do it Saturday. Some people that could do it Friday night, couldn't do it Saturday. But as far as the total count, it ended up just being 2 off. And so I was like, well, because of CalcBC and I talking, because they've taken one of these before, and because of just the fact that the makeup AP is going to be Wednesday after spring break, Wednesday after school. Some of you need to be considering that anyway. Remember, this is your final exam. You have to take it one of those days, either Saturday morning or the Wednesday after we get back in the afternoon. I was like, well, wait a minute. The mock AP, if there's only 2-person difference, the mock AP is in the afternoon, so those who are going to do better in the afternoon have that option anyway. And then those who are like, I'm just going to be beat if I try to do it after school, especially on a Friday. My brain's going to be fried. I'll get it out of the way, but it's a bad idea. I was like, yeah, I think it's a bad idea too. So You guys are going to be able to go home, study your forever cards a little bit, get a good night's rest, just like the actual AP will be. Come back Saturday morning, bust it out, and then be like spring break. And A-Bers will leave at noon. B-Cers will have the option of me treating them to lunch or coffee or something or others, and they're going to stay and grade the AB FRQs, which will help me tremendously. They've done it for the last 3 years, the last 2 years, starting with George Corey's class. Because if you guys think about how many FRQs are there for you on an AP exam? 6. And all 6 need to have how many different points graded? 9. And how many kids are in my classes? And I have a Baja mission trip that I'm going to be gone Monday through Friday. So just thinking about realistically, it's too much for me to handle. As my classes started growing, I started becoming like staying up multiple nights in a row trying to grade these things. And think about it this way. BC grading AB FRQs, it's a good learning opportunity for them, and they're going to be making tutorial videos on the AB FRQs about the mistakes that were made, and you'll be able to learn from their grading and analysis. Does that make sense? So it's cool for you guys to be able to get a perspective from someone other than me. I mean, you'll have my perspective, you have it every day. And as we go through AP review, etc., but you'll also be able to learn from their perspective, being like, oh man, they're making these mistakes. Guys, come on. When you see this, and you're going to be able to hear them presenting video explanations of each of the FRQs that you take. There are different exams for the Saturday one and for the Wednesday one. So the FRQs will be different, the topics covered will be different. They're both going to be an AP exam, just they're going to be different ones for obvious reasons. So in that way, BCers, there's going to be more than enough for them to work through in their projects as far as they have 12 FRQs to explain to you. But they get a little bit of, they get benefit out of it as well, as far as you guys know, if you can teach something, if you can grade something, you have a deeper level of understanding. So anyway, all that to say, it has been established, the date has been set, the time has been set. But we need to get back to Chapter 6 because we are right here on the edge of finishing our CalcAB content and being able to AP review, both for the Saturday mock AP, your final exam, and for the actual AP. So let's talk through what you guys did here. Areas, number 6, back of your homework spiral, beginning of class, as you were working. What was the very first thing you guys considered? Were they equal? Okay, come on. I need something. I need just voices. I need talking. When I ask you a question, just whatever pops into your brain. What did you think of first? Bounds. Perfect. So most of you probably wouldn't have thought of the picture, which is a good thing, because why is this so weird? Oh, it's because I have the picture off to the side. I forgot. I was hiding it. Anyway, we'll see the picture in a second. And even though the picture might be useful, some of you just saw it. Long story short, it's hard. It's hard. And it's much, 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 much better to think of the bounds. So, yes, bounds, because they weren't given, they were natural. And when you guys set this equal to each other, uh-oh, what ended up happening? There's a cubed. Ah! But was it impossible? No, it was super easy, because if you move it all to one side, didn't every single term have a y? So you guys had your y cubed, you had your minus 5y squared, you had your plus 4y equals 0, and then didn't you factor out the y? And you got y squared minus 5y plus 4. Didn't you guys factor? And you got y and y minus 4 and y minus 1 equals 0. So your y's were 0, 1, 4. Oh! 3 intersections. So what'd you do with those 3 intersections? Okay. So how many different integrals did you set up? Nice. Because just looking at the numbers, you're like, well, if I have multiple intersections and if I'm making them, I have to split it up. So splitting it up, going from 0 to 1. Wait a minute. When you make an integral expression, what do you have to do with area between as the direction? Absolute value, and also how do you put the two functions together? Multiply, divide, add, subtract. Subtract area between. So which one did you guys put first, the y cubed or the y squared? Sure, that's fine. So the y squared minus y, all minus, not times, lo siento. But if you didn't have the picture, Did you really know which way you were supposed to unless you started like plugging in points and trying to figure it out? No. Wait a minute. We talked about the sign as far as the end of the problem, but right here, remember, we don't take an integral with the absolute value inside. We want to pull them out, but in order to pull them out, what do we have to consider? Bounds, and whether or not we need to split it up at zeros, and the zeros are the same thing as the intersections. So will there be any problem between 0 and 1? So what are we allowed to do mathematically with those absolute value? Pull them out and consider them later? Because we already split up at the bound, guys, we're just going to consider the absolute value later. Just in case some of you either didn't think about it at all and randomly pulled the absolute value out without thinking about it, or whether some of you were like, I don't know what I'd do with the absolute value. Although if you're plugging it in your calculator, is it really that big a deal? Can't you just put the absolute value inside? Okay, but that's just one expression. What else did you need? Once again, no problem. We can pull the absolute values out because we're going to go from 1 to 4. We know those are the only intersections. And didn't you guys already figure out what happens when you subtract these guys? Did you do the same way? Just the y squared minus y? Okay, now I know you have your calculator. But ultimately, if we were trying to do an integral expression, technically you would have, the AP wouldn't have left it all nasty and split apart. They would have combined all the like terms. You guys already saw what happens up above when we get all the like terms. So I guess a nice way of writing this integral expression would have been 0 to 1. If we would have gone ahead and done the subtraction and gotten negative y cubed, what would that have been? Plus 5y squared, and then minus 4y dy plus 1 to 4, once again, of our negative y cubed. Have I looked at a picture in any way, shape, or form? No. Without solving this by hand, just plugging it into your graphing calculator with the absolute value, you would have absolutely no idea as to whether or not our orientation was correct or not as far as our subtraction. Now remember, our expression is fine. It has the absolute value. But we don't honestly know whether or not the orientation was correct unless we solve it by hand. And at the very, very end of f of b minus f of a, anti-deriving, plugging in our bounds, fundamental theorem of calculus, we wouldn't know until the very end, and we look at the answer and say, okay, finally, after all of our work, are you positive? Keep it the same. Are you negative? Switch. Did I get the orientation right, or did I get the orientation wrong? Ultimately, this is the graph. Graphing the function y squared minus y is this parabola, and graphing the function y cubed minus 4y squared plus 3y as well. Now here's the weird thing. Kiddos, can we put x equals into our calculators? Because what is the button that you guys go for in function mode in order to graph? Y equals. So could you have pretended this was y equals with x's and y equals with x's? Yeah. But would the picture have looked at like this on its side? No, it would have been the inverse. Do you guys remember what inverses do and how they're, because this one, the x's and y's are switched. So if you did put it in your calculator, it would have all been vertically oriented. How can you picture or visualize vertically oriented if it needed to be its inverse instead? What's the relationship between a function and its inverse graphically? The x and y values switch, and what does that end up doing to the graph? Think of ln and think of e. They're inverses, and how are they related? No, nobody from pre-cal or algebra 2? How inverses? How about square root and x squared? How about cubed and cubed root? How are they related? Flipped across? Not horizontal, not vertical, not the y-axis, not the x-axis, but they're reflections across, not the origin, because the origin would take it here and move it over there. The axis of symmetry, because that would just be around the vertex. Whoa! Wow, I did not think we would be this bad at this. Hold on, hold on, hold on. There's E, there's LN. It's not reflections across him, or across him, or across him. That would be like way down there somewhere. What are they reflections across? Not the vertical asymptote. There's no such thing in this graph. The y equals x line. Ah! Right? It flips. How about, well, we won't do like inverse. The x cubed and cubed root. Do you see it? Give me a thumbs up if you're even like awake and alive and saying, yes, I see it flip. Does it flip? Yes. Across the y equals x line? Yes. So I want you guys in your graphing calculators really quickly to graph y equals this guy and y equals this guy. And I want you to see if your brains could possibly comprehend how this is the actual graph. Calculators won't give you that. I had to do something very specific and very kind of weird to get that exact picture. It's not going to look like that. If you do y equals, it's going to be the inverse. But could your brains have flipped it? Could your brains have flipped it in your mind, seeing the relationship? Y equals x cubed minus 4x squared plus 3x, and x equals, he's hidden behind, y equals x squared minus y. Could your brains have flipped it? Maybe yes, maybe no. I'm not judging if it's a yes, I'm not judging if it's a no. I'm just asking, could your brains have flipped it to make it right? Do you see how it flips? So looking at your graphing calculator, you have it, and it's going this way, right? Isn't it going this way? And what needs to happen? Right? It needs to invert, or I should say reflect across the y equals x line. Now, technically, mathematically, did we need these pictures? No, this is the correct answer. But in thinking about our orientations, and some of you are going to want to use your graphing calculator if given something gross like this on the AP. Do you see how properly the parabola, which would have been x2, I should have done x2 minus x1 for my expression for right minus left for the first area. My parabola was on the right and my cubic was on the left. Or in yours, I think, isn't the parabola on top and the cubic on bottom? Oh, so we can just look at the top and the bottom to know how to do it? Yes, but if you went finding the intersections with your calculator, you would have needed to look not at the x's, but at the y's of yours. No, that's backwards. Not at the y's, but the x's. If you guys actually use your calculator to find the intersection points of what you have graphed, the x's of the original are the y's of the inverse, and that's where it gets tricky, is if you use your calculator. Mathematically, it's way easier, if it's possible, to solve with factoring. But do you guys see with the next one? Who's on the right now? Or who's above now? It was the parabola, but now it's the cubic. So for this guy, it would have done x1, or it would have been x1 minus x2 instead, if you were to set it up. But once again, if you were to find intersections with yours being all flipped, you wouldn't have been looking for the y's, you would have been looking for the x's. Some of you might be doing that right now, or thinking about it right now and being like, oh yeah, I see it. X equals 0, x equals 1, and x equals 4 are my intersection points, which lines up with y equals 0, y equals 1, and y equals 4. What happened if someone put in these correct expressions? What happened as a decimal for this area? The area between ended up equaling 11.833. Any other groups match up with that? Cool. So long story short, can the picture still be useful? Yes, but can it be hard to get? Yes. If any of you guys are curious as to how I got this graph, you go to mode, you go to par mode, parametric functions, because parametric functions allow you to graph x equals. And what you could have done, my orientation's off, isn't it? What you could have done is you could have, in par mode, when you had x1 of t equals and y1 of t equals and x2 of t equals and y2 of t equals, in your par mode, there is an x equals. So you could have actually been like, hey, x is equal to t cubed minus 4t squared plus 3t, where y is t. We saw parametric mode last year. And then for the second one, you could have said x is equal to t squared minus t, where y equals t. But then you would have needed your t min and your t max. Wait, if I'm talking about mins and maxes, where am I at right now, guys? Nope, I'm in window. I'm in window. If you're in par mode, your variable button is a t. You probably would have wanted to make your t something like, I don't know, you could do negative 2 pi to 4 pi. Or negative 10 to 50, or I don't know. You need your t negative because that will graph the graph below and graph the graph above. If you guys remember, par mode is built on time, and time I have to give it enough time to show my whole picture. So there are a few weird things about getting that perfect picture. And the sad thing is, in par mode, you can see the picture. If you guys hit second trace, isn't second trace where all our cool features are? If you hit second trace in par mode, there is no intersect feature. The thing is, you could get the picture, but you couldn't get the intersections, which is why I'm like, hey, that whole inverse relationship, you can get the intersections in function mode and switch the x's and y's, or you can get the picture in par mode and not get the intersections. I don't know. It's a little rough even going for the pictures, which is why I had you guys do all the work of solving without a calculator first. All right, cool kids. That was kind of the nastiest you could have seen as far as setting up a graph that would have been really hard to get from your graphing calculator. And so I wanted to see how you could do without being able to visualize as well. But let's go ahead and grade, because homework wasn't all that bad, right? Shouldn't have been. Because remember, it started off just by saying, hey, here's a picture. Can you show me an integral expression? Whoa, number 6. Hold on. What's with this 2 in front and only one integral? I thought when I was looking at the picture in the book, there should have been 2 different integrals. Because how many different areas between are there, guys? 2. So guess what? This is not the only way to write number 6's answer. This is one way, and this is a very AP way. You might want to, with a colored pen, you might want to make a special note on number 6. Write down this answer. This is right, but this is using what we call symmetry. Remember even graphs? Even graphs that are symmetric around the y-axis, I can take the area to the right and double it to get the area to the left. The other way of doing this one from the picture is you could have gone from 0 to 1 and then 1 to 2. You could have done both of those, except your orientation would have had to have been flipped unless you, the orientation would need to be flipped unless you used absolute value. But you could have gone from 0 to 1 of, I believe your cubed was on top, your line was on bottom, and then you could have added, going from 1 to 2. Now your line was on top, and your cube was on bottom. Or, that's one way. You could have actually been like, who's on top, who's on bottom, who's on top, who's on bottom, put them together. Or you could have done just 0 to 2 of the absolute value of, I don't care, one of them minus the other one. Absolute value will deal with it. That's an or. Or this guy. So there's a that one, or there's a that one, or there's a that one. They're all the exact same thing. If you plug this one or that one or this one into your calculator, they're all going to work. Because absolute value will split up at the intersection point of 1 and will go ahead and handle them separately. This one is the splitting up and is handling them separately with the correct orientation. And this one says, wait a minute, aren't they, no comprendo, aren't they the same area? Well, if they're the same area, why not just find one and say times 2? Cheating. But good cheating, saves you work. Okay, sorry. That's a very good AP-ish. The AP loves to do this whole doubling thing. So I wanted you guys to recognize it. Okay, sorry. Going back to the answers, that was number 6. Number 18. Was that a graphing calculator one? Oh, no. Didn't say to use your graphing calculator. So this one was the one it wanted you to do in terms of x and in terms of y. Top minus bottom was pretty easy in terms of x as far as throw in the line and throw in the parabola. Finding the intersection points, the natural intersection points, which you could kind of see on the graph. There's our, in terms of x, 125 over 6. In terms of y, though, way harder. Because in terms of y, I had to do positive root y minus negative root y, which is 2 root y, to go from 0 to 2, no, sorry, 0 to 4. And then from 4 to 9. It's a different right, which was the line, minus a different left, which was the negative square root. So minus a negative, also 125 over 6. Long story short, top minus bottom, so much easier. Right minus left, it was parabola to parabola, line to parabola. We had to split it up. Ugh. Technically possible both ways. Technically possible both ways, but top bottom was the natural, easier way that you should have done it, if you had a choice. Number 22, that was a solving by hand one. Remember, we're supposed to practice solving by hand and using our calculator. This was a solving by hand section. We find our bounds from 0 to 4. We have our top being our parabola, our bottom being our line. Boom, boom. But if you guys didn't want to deal with that, you could have put absolute value around it, maybe gone the wrong way, but fixed it at the end. Final answer is 32/3. Final answer is 32/3. Number 40. Number 40. He also did not say you were allowed to use your calculator, so he would have needed to be solved. Whoa, where's the 1/2 come from? First of all, you guys might have gotten stuck setting these two equal to each other. That might have been a little messy. We'll talk about that in a second, where the bounds came from. But guys, how did this anti-derive to be that? U sub u equals 2x, du equals 2, divide by the 2. And then integrate. Okay, so the bounds. How'd you guys find the bounds? How do we always find the bounds? Okay, but when you set cosine of 2x equal to sine of x, what the heck do you do? Oh, the bounds work? I was looking at the picture. They gave the interval. Wow, I'm just going to give up because I don't know what's going on my board. Let me check it. Thanks, Janelle. I thought I just saw... They gave you A and they gave you B, but what did they not tell you in giving you A and B? Whether or not there was an intersection. Yeah, so the one dilemma is technically without a graph, remember we'd have to do absolute value of these guys from here to here. And to pull the absolute value out, we would need a picture. So you could have gone, except it didn't say you're allowed to use your grapher. You could have tried to think about what your picture would have been. And if you got your picture, okay, fine, good. There's the left, there's the right, there's no switching, there's no intersecting. You're right, you could have just gone for it. The dilemma is what if you didn't get a picture and you couldn't do that without a graphing calculator. Does that make sense? Yeah, so I like that you start at negative pi over 2 and go to pi over 6. That was given, but they didn't tell you whether or not there were any problems in between. I'm trying again just to see if maybe this time it'll work. I swear my computer's possessed. Because I've seen stuff like this on the AP. What do you do? Let's say we can't just throw in the absolute value to our calculator and have it do the work for us. What do we do? What if we don't know? How do we solve? Forever card 1. Isn't there a double angle property for cosine of 2x? And isn't those sine squared of x? And couldn't I move it all to one side, actually move it all to one side, and get 0 equals 2 sine squared x plus sine of x minus 1? And isn't this technically a factoring problem? Where I can do 2 sine of x, that'll get that, 1 and 1, that'll get that, and then think about my outer and my inner. Well, if I have a 2 minus a 1, that'll get 1. So where are my intersections? Anytime sine is 1/2 or anytime sine is -1. And aren't those unit circle values? Sine's going to be -1 at 3 pi over 2. Which 3 pi over 2 isn't even in this interval, right? Negative pi over 2. Oh. It would be, it's the same position as negative pi over 2. But that's going to be one of our bounds already, so that's okay. If you guys notice on your picture, it does intersect down there. But then when is sine 1/2? Pi over 6, right? And 5 pi over 6? 5 pi over 6 is too big for our interval, but pi... Oh! Don't worry, the intersections are the bounds. So do you have any problems in between the bounds? No, but could you have? Oh, that would have been a mean problem. Yeah, you could have. Final answer, 3 root 3 over 4. 3 root 3 over 4. Number 82. Is that one of those nasty ones like we just did? Yeah. Well, I was thinking it was nasty just in the sense of, doesn't it give you one of these nasty, like x with y's? Just looking at it, what would you guys want to make it, dy or dx? Yeah, I don't want to get y by itself. How do you even do that? You don't. You can't. So you're like, no, I want it in terms of y. So if I were you just looking at this, it needs to be dy. So this guy's written wrong, right? Wouldn't you have to solve for x to get them both in terms of y? So subtract the 2, divide by the negative. That's what work you're going to see in the answer key right here. Because they said, no, I need them both in terms of y. Then I can just do a subtraction with an absolute value. If you were allowed to use your calculator, this one technically, you can see this is a by hand one. This is a non-calculator one. But you could have taken both of these expressions. Now that x is alone, set them equal. Your bounds would have been -1 and 2. Since those are your only intersections, you don't have to worry about splitting up. So they went ahead and used -1 and 2 dy. They subtracted. You could have thrown absolute value out there if you're like, I don't know who's on top and who's on bottom. It's okay, absolute value. Solve, 9/2. Okay, I know we don't have tons of time. I tried to cover the tricky ones I saw in the evens. Maybe some of you need to come back to the video and listen to those even explanations again. Especially, I slowed down on the ones I thought were trickier, but do we have any odds that we couldn't figure out how? AJ? 51. Anything else besides 51, guys? No? Okay. 51 gave us the ability to use our graphing calculator. Gorgeous. The ability to use our graphing calculator. So if we're allowed to use our graphing calculator on 51, I'm just going to take a picture of the problem. Did we have to solve by hand for the intersections of x squared equals 4 cosine x? Thank goodness. Because there's no mathematical way to do that, at least not. Yeah, no. So when you guys put this into your graphing calculator, and you tried to graph, which if my graphing calculator was happy and nice and doing what it should on my computer, I would pull it up. But Mrs. Christensen is trying to figure out what's wrong. You guys are in radian mode, right? No one in pre-cal borrowed your calculator and put it in degrees? Okay, good. So we have x squared. We have 4 cosine x. Do you guys have any idea what window you're looking in? Did they give you any idea of bounds? No. So I guess we're just doing zoom standard. And when you're doing zoom standard, hopefully it was fine because you had your parabola, and then over here you had your little guy graphing, right? No, technically. I apologize. I think it's actually pretty symmetric. So it should have been more like that, right? It's nice and pretty. What can you do on your graphing calculator? Can't you find these guys? And then can't we do top minus bottom, and you can already see it, that we're going to have cosine, 4 cosine of x minus the parabola. Because my cosine's on top, my parabola's on bottom, and when I do my intersection answering first curve, second curve, guess. We end up with nasty things like negative 1.2. Guys, what do you think you should do in terms of numbers? Am I rounding yet? Nope. But then, AJ, remember I said you were allowed just to plug this in your calculator and go. Is that cool? All right, kiddos, here's the dealio. Did we get to section 6.2? But what are we covering all week next week? So guess what I'm going to post in Google Classroom, asking you guys to watch 2 different examples of 6.2a that I want you to watch, and then post a comment comparing which one you like better. Sound good? Get out of here. Bye, guys. That's homework for the weekend. I'll get it in Google Classroom by the end of the day. Bye, guys.